This example belongs to the first case in trigonometric substitution. The first case in the square root, you see there is a constant square minus x squared. So in this integral, the constant a is equals to 4 because 4 squared is equals to 16. So since that fits to a squared minus x squared, we have to let x equals to 4 times sine of theta, because this is in dx. All right, so in order to start the first step is we change all the x to theta. So we let x equals to 4 of theta. So to handle this dx, I have to take derivative on both sides. So dx is equals to 4 times cosine theta d theta. So I just figure out a way to rewrite the dx. The dx is now 4 times cosine theta d theta. So if you look at the given integral, there are three components, the x to the third, the square root, and the dx. We just rewrite the dx to theta. And then what about the x to the third? The x to the third is equals to, you just take whatever you let x equals to, and then raise that to the third power. And then the square root, the 16 minus x squared, is 16 minus 4 times 4 is 16, and then sine times sine is sine square theta. And then for the entire square root, so you have 16 minus x squared, that is 16 minus 16 sine square theta, and then you factor out the 16. So you have 1 minus sine square theta, and then 1 minus sine square is equals to cosine square, and then take the square root on the whole thing. 16 square root of that is 4, and then that get rid of the second power, so that is 4 cosine theta. So and then you put all these three components back to the integral. So after you are done, the integral is in d theta. So the top, the x to the third, is now 4 times sine of theta, and then you raise to the third. And then the bottom, the square root, that is 4 times cosine theta, and then the dx is in the yellow box, that is 4 times cosine theta d theta. So there is an obvious simplification, so you can get rid of the 4 times cosine and the 4 times cosine. So the 4 to the third power is 64 times sine to the third theta d theta, and then we have to work on the d theta. So for the third power, I am going to put the third power as second power times the first power. And then I am going to rewrite the second power as sine square, right? That is equals to 1 minus cosine square theta d theta. Oh, totally forgot the sine, right? Sine theta and then d theta. Okay, and then I'm going to do a u substitution right here. So I'm going to let u equals to cosine. So du is equals to negative sine of theta d theta. So 1 divided by negative sine theta du is equals to d theta, and then this d theta is going to go right there, and then after the substitution is done, the sign will be cancelled. So you have 64, and then integral 1 minus u squared, and then after you get rid of that, you only have maybe I should write the whole thing, times 1 divided by negative sine theta du. Look how obvious that is. So after you cancel the sine of theta, so let's do the job 2, and then you have a negative 1 over there, right? So you have a negative 1. So how about this? Let's just take the negative 1 out. So we have negative 4, and then the integral of 1 is equals to u, the integral of the square, that is 1/3 u to the third, right? And then you put the theta back, negative 64, and then you have cosine of theta minus 1/3 cosine to the third, not square, cosine to the third theta. We don't need to do the plus c yet. So now what did we do? We started at dx, and then we do the change of variable, change everything to d theta, and then we integrate the trig integral, and then the result is there. And then since the problem is in dx, we already integrate that, but we have to go back to x, right? How do you go from theta back to x? We cannot do any more substitution. The substitution is already done. So to go from theta to x, that is the next stage. The next stage is you have to use the right triangle trigonometry. So let's draw a right triangle first. So this is my right triangle, and then 90 degree, and then here is the theta. So what do we have right here? how do you do the next line? The next line, you have to go back to your very first step. So if you go back to the first step, do we agree that we let x equals to 4 times sine of theta? That is the very first line you wrote. Okay, so we let x equals to 4 times sine of theta, then sine of theta is equals to x divided by 4, and then we have to use the right triangle trigonometry, the SOH. SOH. So S is equals to opposite divided by hypotenuse. So the hypotenuse is 4, the opposite is x, and then what about the adjacent? So to figure out the adjacent, here is what you can do. You can recall the Pythagorean theorem, a squared times b squared is equals to c squared. So a squared plus b squared is equals to c squared. If you don't know a, then a squared is equals to c squared minus b squared. So get rid of the square on the left hand side, and then you can just do a square root. So that means this is equal to 16 minus x squared. So now we got all 3 sides figured out. So what is cosine of theta? So cosine of theta, why do we do cosine of theta? Because we have cosine of theta. That's why we have to do the cosine. So CAH, the car, so that is adjacent divided by hypotenuse, which is the square root divided by 4. All right, so that is what cosine is. And then we proceed to put the theta back to x, so we have to go back to pink. So we have negative 64, right? So we have negative 64, and then cosine of theta, so that is the square root of 16 minus x squared divided by 4 minus 1/3, and then the third power, then you have to take that thing to the third power, so the 4 to the third power, and then the square root to the third power, so square root is 1/2, right? So third power means you have to take the 1/2 multiplied by 3, then that becomes a 3, and then that's it. So this one is the final answer without any simplification. Of course, you have to simplify that a little bit. How about distribute the negative 64 to each thing inside the parenthesis? So 64 divided by 4, that is 16. So that is negative 16 square root. Negative becomes a positive, so that is a 1/3. And then 64 divided by 64, right? 4 to the third is 64. Then the entire denominator is gone. Then you have 16 minus x squared, and then raised to 3/2 plus c. To me, if I ask my student to do this on quizzes and exam, I would take this as the final answer. You don't need to simplify any further. But can we simplify further? The answer is yes. So what you can do is you can factor out a negative 1/3 and then factor out the square root as well. After you do so, this becomes a 48, because 48 divided by 3 is equals to 16. So how do I get the 48? I take 3 multiply 16. And then you took a minus out, then this becomes a minus then. And then this is a 16 minus x squared raised to the first power plus c. First power plus 1/2 is equals to 3/2. I know you might say, I don't really like doing this. Why don't we just take that as the final answer? Yes, when I ask students to write this on exam, I just take that as the final answer. But if your instructor has special preference, then you have to follow that special preference, right? And then you simplify the parenthesis, so negative 1/3 square root, and then 48 minus 16 minus plus c. So this is the final answer in the simplified final answer. If someone prefer you to do so, I don't like this. The reason is this is about trigonometric substitution, right? It's not about simplifying an expression. Okay, so that is not the end yet. I would like to discuss another problem. So we just discussed a squared minus x squared, right? So what if I have this problem? So what if I have the integral of x times 1 minus 4x squared dx square? This is a square. Now, do we need to do all the works? The answer is no. This one is just a simple u substitution. All you have to do is you let u equals to 1 minus 4x squared. How do I know? Because when you take the derivative, you get negative ax dx, right? So this x right next to the a is going to get rid of the x outside of the square root. So that's why it is not necessary to do trigonometric substitution. But when you open up your textbook and then you flip to the trigonometric substitution section, they will design the integral in a way that you cannot use U substitution or integration by parts. They will do that on purpose because they want to push you to do the trig substitution. The trig substitution. Okay, let's finish this problem. So you have integral x times u to the 1/2, and then 1 divided by negative ax du, right? So the x is cancelled. You have negative 1 over a, and then u to the 1/2 du. So that is negative 1 over a, so plus 1 reciprocal, and then plus c, and then you put the u back. So that is negative 1 over 12. 1 minus 4x squared raised to 3 over 2 plus c. This is the final answer. Usually the trigonometric substitution at one integral will take 1 page of work. Sometimes more than 1 page. Sometimes you have to take 1.5 pages to do it. So when you do trig substitution on your homework, leave a lot of space and you have to consume a lot of paper. Alright, so this is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. Appreciate for your help and support. See you all in the next one. Signing off for now.